Okay, so this is a video of the Unit 7 examples from the AP selection over polar and parametric stuff. So in this first example, I went through it. You have the graph of a polar, and they're asking you to figure out the area of the enclosed. So we know that the area is going to be 1/2 the integral from 0 to 2 pi of that thing, quantity squared. Now the problem with that is that you go to look for that as an answer choice, and that's not an answer choice. And you're like, well, squares and square roots kill each other off. So you get to here. And again, that's not an answer choice. So this is what I was talking about, where the answer choice that you come up with may not actually be a selection. So what you're going to have to do is look at the other answer choices and see which one would yield the same result. Now, one thing that I kind of noticed when looking at these answer choices is a lot of them didn't have this 1/2. So to get rid of that 1/2, you kind of need to know that this would be a circle. So if I only integrated over, half of it instead of from 0 to 2 pi, if I went from 0 to pi, but I multiplied my answer by 2, that would be equivalent. And that's exactly what's happening in choice D. So I selected choice D. If you wanted to graph that, you could throw that in your calculator. I would predict that this would be a non-calculator question. So if you needed to be able to graph this, you may have to make a table to kind of graph it out. Okay. So moving on to question 2, which of the following represents the graph of the polar curve r equals 2 secant theta? So again, you could kind of start this two ways. You might go with theta and r, and you might make a table. And so, I don't know, you plug in numbers like 0 and pi, and, you could plug in something else. But let's say you plug in 0. So you plug in 0, you get secant equals 0. Well, secant is going to be 0 when cosine is undefined. And that doesn't happen, right? So that doesn't give you anything. So I'm just kind of putting an X there. Because cosine is never undefined. There's no asymptotes like there is with a tangent curve. So then you go on and you're like, all right, well, let me try plugging something else in. So maybe you plug in a pi. So when you plug in pi, secant of pi, well, I know that cosine of pi is -1. So that means that secant is the reciprocal of that. But the reciprocal of -1 is -1. So -1 times 2 gives you -2. Now remember, when you're graphing polar, a -2 means that you're actually moving away from pi. So if you kind of, if you're kind of picturing this, if you're at 0, we don't have anything, right? And then as you're going, when you plug in pi, over here, you're going to be at -2, so you'd be going bing, bing, so you'd have a point here. Okay? So I'd kind of make sure that I would then eliminate, so we talked about wounding it, so I definitely want a point, where this is. So this one's still in, this one doesn't have a point there, so you could get rid of that. This one doesn't have a point over there, so you can get rid of that. This one does have a point there, so you can't get rid of that. And then this one, this is going at -2, so that would be the mistake that I made if I didn't know that when you got polar, you went away. So those are actual elimination techniques. So what did I just say? I was able to eliminate B and C and E because of that elimination. Okay? And then if I know that 2 cosine, guys, 2 cosine theta, that's going to be a circle to the right. This is actually the graph of 2 cosine theta, not 2 secant theta. So you could kind of eliminate that one because you're like, well, that's the graph of 2 cosine. So that kind of leaves you with this. But why else would that make sense? So if that isn't a good enough justification for you, think about what would happen if you multiplied both sides with a cosine. So if you multiply both sides by cosine, you're going to get r cos theta, and then 2 secant theta cosine theta. Did I cut that off? And r cos theta, well, r cos theta you should know from pre-calculus. R cos theta is the same thing as x equals, and secant times cosine, well, secant times cosine, when you multiply anything by its reciprocal, you get a 1. So 1, right, this part equals 1, times 2 gives me 2. So x equals 2 is the line I'm looking for, which is D. And again, you could have kind of gotten there from elimination. Some people might say, well, I wouldn't have multiplied both sides by cosine. Well, that's fine if you wouldn't have kind of, multiplied both sides by cosine, you still should have been able to get the answer using kind of a table and some elimination techniques. Either way, you get that the answer is D. Okay. So then, I know these are misnumbered. Sorry, there's 2 number 2s here, but so we'll go on to this polar question. So in this polar one, which of the following is equal to the area inside of this and outside of that? Okay, so it sounds like we might need a sketch here. So I'll just graph it over here. Okay, let me maybe color code. So I'm going to graph this one. I'll do in this kind of pink. So 2 cos theta, that's going to be a circle with a diameter of 2, and it's going to be kind of 2 to the right, since it's cosine. So you've got this circle here for my quick sketch. And then let me sketch our cos theta. Well, that's going to be another circle. Okay, but this time it's going to be at 1. So you got a circle there. Okay. So which of the following is inside the pink and outside of the black circle? So really the area that we're looking for is inside the pink and outside the black. So we're looking for this area there. I don't know if the highlighter is going to show up. But that's kind of the area that I'm looking for. So to get that, I would say I'm going to kind of use my sweeping brush technique. And look, I got a little lollipop here, so this will be perfect. So in my brain, 0 makes sense to me. So when I'm sweeping, right, if I go from there and I'm sweeping up, that pink curve is always on the outside. So I'm able to kind of use that formula where that formula says that the area is 1/2 the integration of the outside squared. So again, my outside was the pink, so that's 2 cos theta squared minus the inside squared. So the inside curve was cosine theta squared d theta. And when I do this, I always kind of go from 0, and then I would go from 0 to pi over 2. But the problem with that is, so if I went from 0 to pi over 2, that would only give me the top half, right? So I'd have to take that whole answer and multiply it by 2. That way I'd get the bottom half. So again, the formula, this 1/2 comes from the formula, but I'm going to kind of I have to multiply that by 2 because I'm only going from 0 to pi over 2 because I'm kind of looking at this top half there. And so I go, and I'm like, well, that's not an answer choice, so maybe I clean it up. So this 2 and that 1/2 take each other out. So I've got the integration from 0 to pi over 2. And then I look, though, and I immediately notice in my answer choices that there's not this kind of a setup. So that means that I need to kind of do a little extra work algebraically to kind of simplify this. So when you go ahead and simplify that, remember this squared has to go to the 2 and the cos. So you're going to get 4 cos squared theta and then minus cos squared theta d theta. So if I have 4 cos squared thetas and I subtract 1 cos squared theta, that leaves me with 3 cos squared thetas. And I'm hoping that that is an answer choice. So, the answer choice they have, so they have the 3 then, look what they did. So I ended up with like this being, let me make sure I'm not writing off the page. So from 0 to pi over 2, I did 3 cos squared theta d theta, and that's not an answer choice. What they did is they took this 3 and they popped it out front, so that is equivalent to choice A. So again, that's another case where, you know, the answer that you got originally, you're like, well, that's not an answer choice, so you have to simplify it, and then that's not an answer choice, and even down to here, that's not an answer choice. You need to be able to look at those answer choices and determine which one is mathematically equivalent. All right, and then I know it's really number 4, but the last one on this front page here. So the length of the path described by the parametric equation. So this is just your arc length formula from parametrics. I think we did that on day 1. So remember your arc length formula, okay, is the integration. They are going to give you the bounds of integration. So from 0 to pi over 2. And here it's going to be the square root of dx dt squared plus dy dt, that thing squared, and it'll be the square root of those with respect to t. So, you know, you might be able to do those in your head, but I get really nervous here, so I might kind of write those out separately and then take the derivative. So derivative of x with respect to t, I would figure that out, and then I would also figure out dy dt, and that way you could square them both. One thing that you would want to take note of here from the beginning, remember this is equivalent. I might even rewrite it as cosine t quantity cubed, okay, because those are mathematically equivalent. So then when you want to take the derivative of that, remember it's going to be 3, it's going to be a chain rule, so that'll be 3 cosine t squared times the derivative of the inside. So the derivative of cosine is negative sine. So I'm going to pop the negative there and do the sine t right there. Now keep in mind in the formula you have to take this thing here and then square that whole thing. So you have to be really careful with the algebra here. So when you take that whole thing and square it, so this thing squared, taking this whole thing and squaring it, okay, so this piece is squared, so that negative 3 goes to a 9, okay, cosine squared, quantity squared, makes that cos to the 4th t, and then sine squared will just be sine squared t. There. Okay, so that's the first part. So even kind of just from there, you could kind of probably get to, you know it's going to maybe be one of these answer choices hanging out in here, but I haven't quite eliminated it yet. So now I need to figure out dy dt, and again, I would think of this as sine t, whole thing to the 3rd power. That way when you go to use your chain rule, it'll be 3, recopy what's on the inside, decrease the exponent by 1, times the derivative of the inside. The derivative of sine is cos. So you get to there as your derivative. But remember, the formula says we have to take that derivative and square it. So if I'm going to square this side, then I need to square that. And when I go from there, the squared has to go to there, so that becomes a 9. Sine squared would be sine to the 4th t, and then that's a cos squared t. So now I take these two things and I plunk them in there, and it looks like that is going to be answer choice D. So we have that one. On this example, it's the exact same. It's just an arc length. They're asking you to find the arc for the parametric equations. So you have to take the derivative of x, take the derivative of y, square each of them, and then plug them into your arc length formula, and you get C. So I encourage you to kind of try that one on your own. And I want to talk about number 5. So in number 5, they are asking you to go from velocity to acceleration. So hopefully you know that to go from velocity to acceleration, you have to take the derivative. So you're going to take the derivative of each of these components, the horizontal and the vertical component, and then plug in t equals 3. So I'm going to pause the video and work it because I only have a minute left. Okay, so here I took the derivative. So after you take the derivative, then you plug in 3. I ended up with B. I thought that was a pretty simple one. Hopefully you can do that one. And then the last one, it's another arc length. Be careful when you take the derivative of this. It's going to be, the derivative of sine of the junk is cosine of the junk times the derivative of the junk. So there's a chain rule in there. Also, then the derivative of e to the junk is e to the junk times the derivative of the junk. So just be careful then while you're taking those derivatives. And then when you're squaring them, make sure you know how to square those properly. And you should be great. And we can take a look at the free response in class. Have a great weekend.